Good day everyone. Today me and my teammates are going to present about our project planning. So there are total 5 of us involved in this project planning. Our project is proposed two-story house at Kampung Tebuk Mufrad, daerah Sabak Bernam, Selangor. So for first step of our project planning, we do a project charter. Basically, project charter is a formal document created during the early planning stage. So the main purpose of a project charter is to define the project goals and scope, identify the stakeholders, and set a clear direction for the project team from the beginning of the project. So it is important because it helps to align expectation among all stakeholders, keep everyone engaged, and provide a focused vision for the project execution. In terms of content, a project charter typically includes the project background, objective, scope, and stakeholder, as well as the potential risks and constraints. So as you can see in the slide shows the project overview and scope. It is a two-story house in Kampung Tebuk, Sabak Bernam with an estimate cost 700,000 ringgit Malaysia and a project duration from January 2026 to January 2027. The project focused on delivering the house within budget while meeting quality, safety, and regulatory requirements. Works include cover structural, architectural, M&E, and external work. So for these slides, it highlights the key stakeholders, project risks, and the milestone schedule. The key stakeholder includes the project owner, project manager, architect, engineers, main contractor, and local authorities. It's responsible for funding, design, construction, approval, and service connection. In terms of risks, major concerns include weather conditions, material price fluctuations, logistic and site access constraints, and geotechnical risks. They are mitigated through proper scheduling, early procurement, coordinated site access, and comprehensive soil investigation. Finally, the milestone schedule outlines key stage from project charter approval through to CCC handover in January 2037, ensuring structured progress and timely completion. So this will cover the last two parts of project charter. So it is project constraints and authorization. The key constraints include the project timeline, which requires completion and CCC approval by January 2027, the budget limit of 700,000 ringgit Malaysia, and strict compliance with the approved scope, local authority regulation, and site boundary as well. So any deviation in scope or design must follow a formal change request process to avoid legal or approval issues. Finally, the authorization section confirms that the project charter formally approved the construction and empowered the project team to plan, execute, and monitor the project with the agreed scope, budget, timeline as endorsed by the project owner.
So this project organizational chart for these projects, which is from the owner to the main contractor to the manager and to the professionals and as well as suppliers and subcontractors. In this project, they have a lot of key stakeholders involved. It includes the key stakeholders are divided into two, which is the project team members and external members. First, for the project team members, they have owner. Project owner is also the landowner. They will secure the funding to run the projects by their cash or bank loans. The owner will also hire architect and engineer for building designs. They will hire a main contractor to do construction work via bidding or direct appointment. So they will also monitor the construction progress from the start to completions to ensure the design and regulation compliance. Second, for the main contractors, their roles is to perform construction works. Initially, they will meet with engineers, architect and engineers to understand the designs. The project managers will work on behalf of the main contractors. First, the main contractor will offer the price to owner. After the owner agrees with the pricing, the project manager will apply the permits and then they will order the material for suppliers, monitor day-to-day operation and reports the progress to owners. They will do final inspection after completion of the constructions. For the third one is subcontractor. They are nominated by main contractor to perform the installation work, for example, like plumber, electrician, and carpenter. For number 4 is the architect. Architect will design the building layout based on the owner's inspiration and design concept. They will also coordinate with the engineers to ensure the design feasibilities and stabilities. They will choose the building materials that match the building designs. They will also design the infrastructures such as road, recreational park, and landscaping of the house. Number 5 is the civil and structural engineer. They will design the structural elements based on architectural drawings. C&S engineer also ensure the building is strong to carry lift and dead load of a building. And they will also choose a suitable type of materials and foundations. Number 6 is mechanical and electrical engineer, M&E engineers. They are responsible to design the MEP system. MEP includes plumbing, fire protection, HVAC, sanitary, security, and lighting system. MEP is crucial for health, comfort, and daily needs. The MEP engineers ensure standard compliance during installation work. For number 7 is the land surveyor. Land surveyors are responsible to estimate the precise boundaries of land before construction starts. This is to avoid legal dispute by misusing the neighboring lands. They will do the topography survey on site to identify the slope, underground water, and soil types of the construction site. So for the key stakeholders from external party, they have a suppliers, local authority, and utility provider. For the suppliers, their role is to supply enough material to the construction projects. They are responsible to deliver this material to site on time after receiving the orders. They have to return the defective good and do replacement if there is any feedback from the site supervisor. Number 2 is the local authority. Local authority is the local council that control the use of land. Local council for this project is Majlis Daerah Sabak Benam. Before the project starts, they will review the building plans and designs and ensure the code's compliance. They will issue the permit after reviewing, and after the project is complete, they will issue the CCC. Number 3 is utility provider. They are the companies that provide utilities, for example, like electric and water services. For example, like TNB, IWK, and AIS Selangor. They have 3 main communication flow in this project, which is top-down, bottom-up, and horizontal communication flow. First, for the top-down communication flow, it is a communication flow, information flow from the superior level to the subordinates. For example, from the QS to supplier, so the engineers to the main contractors. Number 2 is bottom-up communication flow. The project manager will behalf of the main contractor report and update the progress to the owners. Number 3 is horizontal communication flow. This is the communication between professionals like architect, QS, and engineers. For example, QS will always lie with others for the building cost estimations.
So hi, I will talk about work breakdown structure. What is work breakdown structure? A work breakdown structure is a hierarchical breakdown of a project into smaller and manageable work components. It shows what work needs to be done to complete project and help in planning, scheduling, costing, and assigning responsibilities. So here are 5 types of work breakdown structure. 1. Phase-based WBS. Divide the project according to project phase, such as planning, construction, and handover. It helps to monitor progress and control work at each stage of a project. Number 2 is deliverable-based WBS. Break the project into clear deliverable or output that must be completed. It ensures all required results are delivered and the project scope control. Number 3, organizational-based WBS. Organize work based on teams, department, or contractor responsible for the task. It improves responsibility, coordination, and accountability among the project parties. Number 4 is product-based WBS. Divide the project into physical or functional building components such as structure and roofing. It ensures every component of the final project is properly complete. Number 5, activity-based WBS. Break work into specific construction activities or tasks. It is useful for detailing, scheduling, sequencing, and site-level control. Next, I will explain about function of work breakdown structure. First, define project scope. WBS help to clearly define the overall project scope by listing all required work activities. This ensures that no important work is left out and help avoid confusion or scope change during construction. Number 2, improve planning and scheduling. By breaking the project into a smaller work package, WBS makes it easier to plan activities, set duration, and arrange work sequences. This forms a strong basis for preparing project schedules, such as Gantt chart and critical path method (CPM). Number 3, support cost estimation and control. WBS allows costs to be estimated more accurately because quantities, labors, and material can be calculated at work package level. It also helps monitoring and controlling project costs throughout the project. So here's steps involved in creating a work breakdown structure. Number 1, define the project objective. Clearly identify the overall goal and the scope of the project to understand what needs to be achieved. Number 2, identify major phase of deliverable. Break the project into a main phase or major work sections such as substructure, superstructure, and finishes. Number 3, need to break down into detailed activities. Further divide each phase into smaller and manageable tasks until they can be easily planned and controlled. Number 4, develop work package. Creating work package that are suitable for scheduling, costing, and responsibility assignment. Number 5, review and finalize the WBS. Check the WBS to ensure all work are included, clear, and aligned with the project scope. So here, the example of work breakdown structure WBS. The work breakdown structure WBS shown use a phase-based approach for the construction of 2-story detached house at Kampung Tebuk Mufrad, Sabak Bernam, Selangor. The project is divided into 5 main phases, representing the key stage of the project life cycle. Okay, so the explanation. Phase 1, project initiation and planning. Focus on early project activities such as project setup, defining scope and objective, scheduling, cost estimation, and procurement planning. This phase ensures the project is properly planned before the construction starts. So next, phase 2, site and substructure work includes site clearing, excavation, footing, construction, and ground slab works. These activities prepare the site and provide a strong foundation for a building. Phase 3, superstructure works cover structural elements such as columns, beam, slab, wall, staircase, and roof structure. This phase involves constructing the main building framework above the ground level. Phase 4, architectural and M&E work. It involves both external and internal work. External work include brickwork, roofing, window and doors, while internal work including plastering, painting, flooring and ceiling. Mechanical and electrical systems are also integrated at this stage. Okay, phase number 5, external work. Testing and handover include electrical and plumbing installation, testing of services, final inspection, and preparing of handover documentation. This phase ensures the building is safe, functional, and ready for occupancy.
For site layout plan, our project location is at Kampong Terbang Mufat, which is two-story residential house. The function of a site layout plan is used to arrange facilities, machinery, materials, structures, and boundaries. It also ensures site safety, smooth workflow, efficient use of space, and proper accessibility during construction. This slide highlights the main site constraints including flooding, site access, and environmental protection. For flooding, the site is located in a low-lying rural area and is affected by seasonal monsoon rainfall, which can cause surface water accumulation, structural deterioration, and higher maintenance costs. To address this, the finished floor level will be raised and proper drainage planning will be implemented to control stormwater. For site access to the site is a narrow, unpaved kampong road with limited turning space, clear site entry and exit point, sufficient delivery and unloading area, and crane access will be provided to ensure smooth construction activity. For environmental protection, the site is surrounded by natural vegetation, agricultural land, and wildlife habitat. This feature provide natural cooling, preserve the rural character, and support the local ecosystem. This is the site layout plan at Kampong Terbang Mufat.
Me and my teammates used Microsoft Project Tools as our project planning tool. Each of us did our own planning. By using this tool, we get a clear objective and scope, effective time and cost control, earlier risk identification and mitigation. Moreover, it also improved coordination and project success. So as you can see in this slide, we have put the example of implementation of project tools. As every of us created our own planning using Microsoft Project, there are differences on our task list, cost, duration, and so on. So now let's talk about the overall project duration. So based on the comparison table on the slide, all projects start on 5 January 2026. Medellin, Limpeh Hua, and Izzatu Sofia maintain full baseline duration with no finished variants. However, Phai Liao showed the most aggressive scheduling, finishing 3 days earlier than baseline respectively, while Amanda will be finished 2 days earlier.
For comparing main task sequencing, we have 5 phases, which are phase 1, phase 2, phase 3, phase 4, and the last phases. All group members apply a consistent task sequencing based on the 5 main construction phases. This slide comprises the logical and illogical task dependency identified in the project schedule. Firstly, logical dependency. Most task dependency follow standard construction practice. Phase 2, which involves site and substructure works, only starts after phase 1, which is planning and approval are completed. This reflects a correct administrative and technical dependency. Next, foundation works in phase 2 are completed before substructure work in phase 3, which align with structural load-bearing requirement. For phase 3 and to phase 4, architectural and M&E works are linked after or partially overlapping the substructure using finish to start or start to start relationship. Although some members adopt a more conservative approach by completing the structure fully before M&E works, the sequencing is still logical, but it results in a longer overall project duration. However, some illogical dependency were identified. External work in phase 5 was scheduled only after all internal finishes were completed. This is illogical, as work such as drainage, paving, and landscaping can be carried out in parallel. In addition, testing and commissioning were scheduled only after all architectural finishes were completed, which reduced flexibility and unnecessary delays project completion. In summary, while most dependencies are logical and technically sound, the illogical sequencing limit parallel working and extend the overall program duration.
So here, comparison of critical path analysis. The critical path represents the longest sequence of dependent activities, determine the minimum time required to complete the project. Any delay in this activity directly affect the project completion date. So here we compare 5 planners based on their critical path length, float, availability, and associated risk level. So here, number 1 is Medellin. Medellin has a tiger's critical path. Most activities are arranged consecutively with minimal float, which make progress tracking clear but increases sensitivity to delay. So number 2, Phai Liao. Failure has shortened the critical part by overlapping major phase, improving time efficiency. However, this increased coordination complexity and project risk. So number 3 is Amanda. Amanda studies show moderate critical part pressure with higher dependency in the middle and final stage. Delay at this point can significantly affect completion. Number 4 is Izatus. Izatus allow float within phase, reducing the impact of minor delay and providing flexibility, especially during finishing work. Number 5, Pehua. Pehua distribute activity duration evenly, creating a balanced critical path with higher fluid, which improve resilience against unforeseen disruption and support smoother delivery. And in summary, tight schedule increase risk but improve tracking, while balanced schedule provide flexibility and reduce delay impact. Each approach has trade-off between efficiency, flexibility, and risk.
So for the comparison of the resources allocation and workload among the 5 Microsoft projects. So first, we have to comparison about the manpower allocations. So efficient manpower allocation is very crucial to ensure every resources is well planned and each stakeholder is allocated with their tasks without confusion and task overlaps. So the table shows that comparison of the total manpower resources number, the manpower with most working hours, average workload, and peak workloads for these 5 members Microsoft projects. So for the comparison of this data, we can summarize that Peihua's plan shows the strong professional manpower details with allocation of multiple engineers, QS, labors, etc. Amanda's plan shows clear core structures with project manager, construction manager, engineers, and trade lab handlers are allocated well. For the Izatu's plan, there is a balanced resource allocation with less peak during finishing work. Hence, it reduces the release of project delays. Phase plan shows the strong trade coverage with the bar bender, bricklayers, and plasterers. While the Madeline plan shows the balanced allocation with moderate workload per resources, hence reduce task overloading. Second, the comparison of the equipment allocations. So from the earthwork and concrete work, so good equipment allocation is crucial to ensure project runs smoothly without delays, because we know that the equipment resources are limited. So here's the comparison. Overall, these 5 Microsoft projects show practicabilities in terms of equipment allocations. First, Peihua plan are well to compaction and earthwork work, as well as structural work like uses of concrete mixer. Amanda's plan comprises strong and retail equipment. It includes lifting, plumbing, and haulage. Izatu's plan includes strong earthwork and logistic support, which improve realism and backfill. For phase plan, the uses of excavators and scaffoldings includes a combination of earthwork and structural work. While lastly, Madeline's allocated a balanced earthwork set in her plan, which improved efficiency for the earthwork process.
Overall, all 5 proposals meet the project objective with total construction cost below 700k. The differences between the budgets mainly arise from the design assumption, choice of features, and construction priorities. Starting with the comparison, FAE allocates a higher cost to planning and preliminary works, which is less common for small residential projects. Amanda spent the most on substructure works, assuming higher foundation and groundwork. Medellin allocates more to the superstructure, which making it strong, but it possibly over-designed the structural system. Peihua focused on finishes and services such as plumbing and electrical works, which is realistic to a 2-story bungalow. Izatus also allocates a high budget to architectural and M&E works, showing attention to interior quality and functional performance. Based on this comparison, the most realistic budget is Peihua's proposal at 690k. It has balanced distribution for all construction phases, allows sufficient budget for finishing, service, and external works. It also aligns with real residential construction priorities, which has reduced the risk of cost overruns. After reviewing all project plans, our group selected Peihua's project plan as the most realistic and achievable based on duration, sequencing, resource allocation costs, and also milestone and critical path management. The first reason for selecting Peihua's plan is it has the realistic and clear project duration. Peihua's plan with duration 250 days, which allows flexibility and reduce delay risk. Most importantly, curing periods for concrete work for ground beam and slab are clearly included. Although curing is not a visible activity, it is essential for ensuring structural integrity and long-term building performance. The second reason choosing Peihua's plan is the logical task sequencing and appropriate use of dependency in Microsoft project. Peihua applied finish to start and start to start relationship to allow certain activities to run concurrently, especially during internal finishing work. In addition, tasks such as defect inspection and rectification activity is included, reflecting a real construction practice where defects are common and must be addressed before completion. Another important factor is effective resource allocation. Peihua plan shows balanced and efficient resource allocation by ensuring that labor and equipment are not double booked. The resources are assigned according to the skill requirements, such as wiremen and plumbers. In terms of cost, the estimated total cost of 690K reflect a more realistic construction budget in the Malaysian market. Lastly, Pei Hua's plan include clear milestone and effective critical path management. The schedule has a clear milestone by including testing, documentation, and CCC application, which has reflect professional construction practice. Besides, the critical path is clearly and well-defined, allowing potential delay to be identified and managed early. Overall, Pei Hua's project plan is the most realistic and achievable among all submission proposals.